Hey there guys, it's Cooper Codes. Today we're going to be looking at the problem reverse a linked list. In this video, I'm going to be going over the iterative approach to solving this problem. We're going to start by looking at some of the basic linked list concepts, assuming that you've had light experience in linked list, or maybe you're a little bit more advanced. We're going to make sure you understand the fundamental ideas behind how you end up solving this problem. Let's get into it. Alright guys, let's get started. So we have our linked list 1, 2, 3. Let's just make sure we understand how to traverse a linked list and kind of what it means to change the .next property of each node in the list. If we can understand this, we can see some common pitfalls beginners make when approaching this problem. So let's take a look at the node 1 for example. So node 1 has a value of 1 and its .next property is the node with the value of 2. And this is specifically the node that's right there pretty much, right in the middle of the list. And so since it's that node, we have to be very careful about changing that .next property. If we were to change this .next property to, instead of this node right here at the 2, right? If we change it to none, we're going to run into an issue because what that's pretty much doing is this arrow in our diagram signifies the .next property, right? That means we wouldn't have an arrow anymore. And so if we didn't save that node 2, that means we've lost access to the entire rest of the list. It doesn't matter if your list is 1 more item or 1,000 more items. You've lost access to everything else. And so that's a huge issue. When dealing with linked list, you really have to understand that changing the .next property is huge, because whenever you change a .next property, that means you could possibly be losing out on the entire rest of your linked list. Alright guys, so I cleaned up our diagram just a little bit. We're using the exact same linked list, right? Except I added a little arrow pointer to show where our head variable is. It's important to remember that head means the first node in our linked list. It doesn't mean anything else. It's not a special node type. There's no head node type of node. It just means the first node in our linked list. Head node is super important. Imagine you wanted to go through your linked list twice, right? If you just use the head node, it would look like this, right? You'd have your head variable, right? And you go head, and then to get to the next node, it would have to be head dot next, right? And so now our head arrow is pointing to here, right? And now we're at 2. So now head is equal to our node of 2, right? And so now we can do 2.next, so head.next, right? And that's going to get us to 3. And then technically, one thing I missed initially, didn't show you guys kind of on purpose, is 3 has a .next property, except it points to none, right? And that's super important because we know when head is equal to none, that means we've reached the end of the list, right? And so one issue that I was kind of talking about before is if we wanted to loop through the list again, we would kind of be screwed in this situation because we don't have access to the nodes behind us, right? That's a super important concept. If we wanted to save our head, we would have to make a saved head variable and set it equal to head. So pretty much what we're doing is if we want to loop back, right, we need to save our head variable initially, right? So an example of what that would look like is, let's just say, I'll move this other stuff out the way. Let's just say we wanted to save it. We can add in a little arrow here, and we could just be calling it, saved head, right? Simple variable name. And so if head moves forward, it will move like this, like we talked about before, but saved head will stay in the same spot, right? And then for a great example of showing you how we could loop through it again, we take head back, right? We pretty much take, when I mean take head back, what we're doing is we're saying head is equal to saved head, the value of saved head. And so that kind of is going to bring our head all the way back. Alright guys, at this point in the video, we've talked a little bit about various LinkedIn concepts, but we haven't really got to the problem of reversing a linked list, right? So I think the great way to approach this problem, especially if you're having trouble with it, is let's draw out together an example of what the reversed linked list would look like. So there's one way to do it. Let's just first, we know that if it's 1, 2, 3, the nodes are going to be 3, 2, 1. So let's just draw the circles 3, 2, 1 with no arrows. So we can worry about the arrows in a second because the arrows are important. Remember, the arrows in the diagram represent a .next property in each node. Hopefully that makes sense. So here we go. So 1, 2, 3 is going to become a 3, 2, 1 because that's the reverse, right? And so now let's think about where are the nodes pointing to, right? Let's see here. So we kind of want the nodes to point like this, right? Going to the right. So 3, since it's going to be our head node, super important. That's why I decided 3 to be our first value here, is because 3 is going to be the head node, right? If you set 1 as the head node and then pointed 1 pointing to 2 pointing to 3, you'll see that's exactly what our list on the top right here is. And so now let's finish up our .next here. So the 2 points to the 1, and the 1 points to the none. Now let's take a look at this, right? I think it's good to go node by node through our top example. So let's look at the node 1 and see how it's changed. Initially, the node 1 was pointing to node 2, right? I'm looking right here, right? 1 is pointing to node 2, right? But now 1 is pointing to none. That's super important to understand. 1 was pointing to node 2, now 1 is pointing to none, right? So that's like the first one, right? So look, because we want to look at every single thing and how it's changed, because I'm trying to bring you guys into the intuition instead of just telling you the answer, right? Alright, so let's write down how each node has changed. So before, the 1 was pointing to 2. Now, the 1 is pointing to none, right? Now let's take another look, right? At the 2 was pointing to 3. And when I say was, I mean at the example on our top, the original linked list we were given before the reversal, right? And so now 2 is pointing to 1. And if you're confused as to how I got 2 pointing to 1, is I'm taking a look at our bottom list, right? And I'm seeing where is the pointer going from 2. It's pretty much 2's .next property is going to 1 in our example on the bottom, right? And so now let's take a look at 3. 3 in our initial example was pointing to none, right? Now 3 is pointing to 2. Hopefully these examples kind of make sense. Now I'm going to get into the pattern if you haven't already seen it. And so there's a specific pattern here that I'm going to go into. Let's go through node by node our original linked list, right? And so pretty much imagine there was a previous pointer node, right? This is going to help us. The concept of previous pointers and like next pointers is super common in linked list questions. So if you're ever confused as to how to approach something, try and think about if a previous pointer could help you or if a next pointer could help you. So we have a pointer that's going before the 1 and a pointer at the 1. The pointer at the 1 would be like our current pointer, right? And so originally, what is that pointer? Well, it would be none, right? Because there's nothing there, we would originally set it to none, right? Now, let's move these forward just 1, right? So now our current pointer is going to move to 2, and now our previous pointer is going to move to 1. You might see what's happening here. What is our previous pointer? Well, it's 1, right? Now, let's move forward again. So our current pointer is going to go to 3, and our previous pointer is going to be at 2, right? And so now let's just mark down what our previous pointer was. Our previous pointer was 2, right? Now here's what's going to happen. Our current pointer, our current pointer, there we go, technical difficulties. Our current pointer is now set to none, so we're not going to move forward, right? Now, look at this. We discovered a great pattern here. Our previous pointer was none, 1, and 2, right? Look at this. In our reversed linked list, it was none, 1, and 2. That's the idea and the concept behind reverse linked list. I haven't seen a lot of videos explain it this way, so I'm hoping this kind of brings you to the intuition of actually finding that iterative solution, right? It's all about looking at the patterns and seeing what you can do. And I know looking at patterns is vague, but what I mean when I say looking at patterns is looking at how your input is handled or shown in the linked list example, and then your output is shown. Write down the inputs, write down the outputs, and try and figure out how they got from the input to the output, right? So hopefully we can kind of understand how this can be coded out, right? I'm going to clean this up and we're going to get into it. Alright guys, hopefully you kind of understanding the pattern that we saw previously, but this is kind of getting into how our code is actually going to approach it. Pretty much what we're going to try and do is set our .next properties to the previous node. Does that make sense? Because remember, think about our first example. Previous is initially going to be set to none. I want to make sure that's super clear. Originally set to none because if you're at the first node, the only thing behind you is nothing, right? Because you're at the very first node. Remember, the head node is always the first node of the list, right? So let's see here. Previous is always set to none, right? And in our reversed list, I erased it here, but we still have the reversed notes on the bottom, right? In our reversed list, our 1 was pointing to none, right? And if you're confused on what the reversed list looks like, I would encourage you to draw it out yourself, and so you can kind of follow along that way. If you're not confused, that's great as well. And so originally it's none. And so we're going to have our current value and then change the .next property to point to our previous. Hopefully that makes sense. And so think about it. Our current is going to point to our previous. Our 1, remember our current is 1, is going to point to our previous, which is none, which is exactly what we want for our linked list, right? Remember this though. Let's look at this. Let's actually make that change I'm talking about, where we take our 1 and we set its .next property to previous, right? Previous is now none, right? There's going to be issues there because look at this. We broke a link, right? That means if we don't save the 2, if we don't save our next node, right, we have no way of accessing the rest of our list, right? And so let's take a look at this again. Let's do it the right way this time, right? What we can do is down here, I will make a next variable, right? And while we have the ones.next pointing to 2, we can save 2 with our next node variable. Does that make sense? We're pretty much saving it because we know we have to change the ones.next pointer to go behind it, right? But we still want to save what it was pointing to, the 2, right? And so now, if we change the ones.next and put it to our previous, right? Which is none, right? Oh my, that was terrible. 1 second. Which was none, right? What's going to happen there is now we actually do have access to the 2 node because we saved it with the next node, right? And what you can do here is you can kind of like jump nodes in a way. We can set the value of current equal to next. That's how we kind of do that jump, because you might be confused. Okay, I know the pointers are out of place. I know we've lost the rest of the list besides the next node, right? But how do we actually get current to the next node? We say current is equal to next. And when we say current is equal to next, what's going to happen is this. Since the next is pointing to the 2, current is now going to be pointing to the 2 as well, right? And so now, when we move our current forward, we also have to move our previous forward. Super important. I'll go a step back actually and say this is an important way of doing these steps is you have to do them in order. First, previous has to point to current, right? So previous is equal to current. That's how we make that jump, right? Now we have to make another jump. We have to move current forward to next, right? Boom. And then, while we are at our new current, we can set our next to whatever it is, right? Those are the 3 jumps. It's previous moves to current, current moves to next, and next moves forward. Hopefully that makes sense. And so those are super crucial operations because, like programming, this is a loop, right? So the same things are going to be happening over and over again, right? So let me do this one a little bit faster, and maybe you'll get an idea of the intuition, right? Okay, we're at 2, right? we now have saved our 2.next, thankfully, right? And so now, since we have 2.next saved, we know it's safe to change 2.next since we have the next node saved, right? And so let's do this. Now we're going to set our current.next, right? Current.next is going to be set equal to previous. Hopefully that's all good there, right? And so now, think about what our reverse was looking like. In our reversed linked list was 2 pointing to 1. Yes, it was. So now we're on the right track. Now we have a decent idea that we can be semi-confident in our answer, right? And so now, same exact thing. I'm going to do the jumps. Originally, we're going to move previous, which is now 1, is going to move to what the value of current is, right? Current is now going to move to the value of next, right? And now, at this current, when current has been changed to next, we can move next forward, right? Now next is going to be none, right? And so now, when we're at the 3, what we're going to do is the same thing, right? We're going to take this arrow, which is the 3's.next property, right? And we're going to make it point to the thing behind it, right? Super important step here. When we looked at our the reversed linked list that we want, right? The head of that linked list was 3, right? So you have to think about, look at your pointers, look at how you're looping through. How can you save that head of 3, right? What's going to happen is our previous is going to move forward, right? Same steps, the 3 steps. Previous moves forward, current goes to next, right? But now next has nowhere to go, unfortunately, right? And we can do some code to make sure that doesn't mess anything up, right? But now think about it. Since current's equal to none, we're going to be done, right? And so since we're done, look at the 1 pointer that's pointing to 3, right? That should give you a good indication of what your head should be, right? We're probably going to want to return previous, right? Because if we return previous, it's going to give us the linked list 3, 2, 1. All right, so now that we have a decent idea of the intuition and how to problem solve it, let's get into the Leetcode. All right, guys, let's get into it. So I kind of cleaned up our diagram a little bit. I took away the original and reversed from the bottom, and I made our linked list back to its original state, so not reversed, right? And so the first thing you want to do when you go from diagram to code is you kind of want to look at your variables. You want to see, what do you use, when do you use it, do you have to declare anything, do you have to save anything? That's kind of the idea, right? And so let's see here. Previous, we know we set initially to none, right? So we can do that there. Now we can look at our current, right? And I'll point it out right here. It's right here's what I'm looking at, right? Current is pointing to 1, right? And so we can say current is equal to head, because that 1 node is our head, right? The first node given to us, right? And so now we can kind of get an idea of how we loop through this code, right? We're going to say while current doesn't equal none. If you're confused on why current doesn't equal none is what we're supposed to do here, you can go back and look at how we went through the array, or went through the linked list before, right? And you'll kind of see why that's the case, right? So now, we know that we don't have a next saved yet, right? Well, good news, we have a current. And so if we know our current node, we know that we can get the .next property, right? Something people get confused on is they're like, oh no, what if it's none, right? That's totally okay, because if current.next is equal to none, it's not like you're going to get the error that's pretty common where you say none.next, right? You know if you're in this while loop, current isn't none. That's literally at line 16. It's the main point of it, right? It's current doesn't equal none, right? So current.next could be none, but you're not going to get an error from that alone, right? And so let's add that in. Next node, right? Let's just say next for our example, right? It looks like it's a keyword. We'll just go with it for now. So next is going to be equal to current.next, right? And so with current.next, what we're kind of looking for is saying, okay, whatever we're at, we're going to say the next node, right? So now we can get into actually changing the .next property of our current, right? Because remember, one of the goals is to make that arrow, which 1 is pointing to 2, we want 1 to point to none, right? And so let's do that right now. We can do current.next, right, is equal to previous, right? So let's take a look here, and let's do that on our paper. So now we're going to have 1, And now 1 is now going to point to the value of prev, which is none, value of previous, right? And so we still have current, that's important. Current doesn't change, it's .next property changes, right? And since we still have current, let's do our 3 jumps, right? Previous, right? Oh, I'll make the iPad thing go to the side here for a second. So previous is now equal to what current is, right? That's our first jump, right? First jump. Now our next jump, because now we have 1 and 2, they're kind of separated because 1.next doesn't point to 2 anymore, but we saved it through the next node, right? So now let's do our second jump. Current is going to be equal to next, right? Second jump, right? And this is kind of not super intuitive, but I was talking about the 3 jumps before. Our third jump is actually this one at the top, because it's going to loop through again if current isn't equal to none. This isn't super intuitive, but the third jump is actually at the top of our while loop. It just made sense to call it the third jump before, because when we were doing it on paper, it kind of was like the third jump, right? But realistically, you're making that jump again at the top. An important reason why you make that jump at the top is if you look at this line I'm highlighting right here, right? If next, for any reason, is none, right? And we tried to do, next is equal to current dot next down here, right? We could run into the issue where it's none dot next. You may have ran into this trying to solve the problem yourself. So it's important to realize that none dot next is one of the huge issues in linked list problems. So it's important that we did that at the top, because remember, at the top, we always know one important thing. The current does not equal none. So it's gonna be like 3 dot next. It's gonna be like 10 dot next, whatever the value of the node is, right? Whatever the node is, right? But we know that even if it's not next is none, we can still access that none, right? We run into issues when we say none dot next. It's gonna give us an error, right? And so, as we've stated before, if you look at the other slides, returning previous is what's going to be most beneficial for us, right? When we return previous, it's going to help us the most, and it's going to give us that last value, which is going to be our head, right? Because if imagine with a linked list of 1, 2, 3, you'd want your reversed one to be the 3 at the very end, right? And so it would instead be, you got your current's at 1, you loop to 2, you loop to 3, then you're at none, but your previous is lagging behind you. It's at that 3, which you want to be your new head node, right? And so that's why we return previous, right? And so let's take a look here. Fantastic. And so this was kind of an in-depth way of viewing this problem. I know there are more simple problems out there, right? Or there are more simple explanations of this problem out there. But this video is definitely for the person who's beginning at Leetcode and kind of wants an idea of how everything works. I know just because of the video's length, I didn't go back into things in detail over and over again. Or I kind of did in some areas for the really important stuff, right? But I wanted to make an emphasis on some of the key important things, but I did definitely gloss over some of the other things. If you're still confused on this solution, I would 100% recommending finding a Python debugger, right? Whatever you like to use, and going through step by step. I know the Leetcode debugger you have to pay for or something, so don't worry about that. If you don't have premium, that's fine. Just find some Python debugger online and go through step by step, understanding why the code works. All right, guys, thanks so much for watching the video. I hope you enjoyed. Thank you.